Hello, and welcome to yet another Clarity for Climate Resilience webinar. This one is dedicated to the traffic infrastructure and what we did with it in the project, the climate resilience of the traffic infrastructure. And the traffic infrastructure presentation was usually only made in Spanish because that's where the main market is. But since there is a huge interest in this topic, we have decided to make one also in English. And this is what we are going to show today. If you don't know it already, we are talking about the results of the Clarity project, which is a research project which was co-financed by European Union, 17 partners, quite a few of them in Spain, where this traffic pilot was held. Good. So this is about Clarity for Climate Resilience webinars. We will give you the information where you can find the recordings of them. I think you already must have it, but doesn't matter. Oh, here it is. So events, My Climate Service, where you registered, is also where you will find the results, but also we have a special video platform on GoToWebinars. And now let's go to the panelist presentation. And I have here nice pictures of us. And you will notice that some of us are missing at the moment. So we have a problem, medical problems with Jose, and we are not sure if Luis will be able to join us. But today with you, Laura, Ernesto, and me. So Laura, please start.
Yeah, hello, good morning. Thank you very much for joining us to this webinar. I hope it will be of your interest. I am the head of the infrastructure department at CEDEX, which is a public body which depends from the Ministry of Transport. And also we work for very intensely for the Ministry of Environment in Spain. And we are happy to present the results of this project in Spain and for all the practitioners that might be interested in this topic.
Okay, Ernesto.
Hello, yes, hello, good morning. My name is Ernesto Rodriguez. I am the head of climate modeling and evaluation at the Spanish Meteorological Agency. We have contributed to this project with climate information supporting the different prototypes. Thanks.
Okay, so I'm Denis Havlik. I work for Austrian Institute of Technology and I'm coordinator of the project. And you notice that at the moment we have two people missing. We have some health issues at the moment in Spain. So I expect that Jose Cubillo will join us shortly. And at the moment we are not completely sure if Luis will make it or not.
Yes,
it would be very nice. Ah, there you are, Luis. Okay, yeah. Please.
I'm sorry, I have not the screen, but I'm the web screen, but I'm here. I have some problem with the connection with my computer because I'm not in the office right now. But anyway, I'm Luis Torres. I'm working in Meteogrid. Meteogrid is a small company, but very dynamic company that is working on meteorology and climate change and in natural hazards related problems. So it's all I can. Yeah, we have been working in Clarity in coordinating the Spanish pilot.
So Luis is the driving force behind this traffic application, and if everything goes wrong, he should be able to demonstrate it. Yeah, if everything goes well, he should be able to demonstrate it. As you hear, he has some problems with network at the moment, but usually he is the one demonstrating it. And so when we finish with these presentations, I hope this will be possible to do. As for the last missing part, Jose, well, he is the head of the operation, so to say. Acciona is a big company which is in charge of traffic infrastructure management, and they are the ones who really need all this, and they're the ones who are pushing it further on the business level. So without further ado, let's go to the next step, which is who is today with us. Now, we usually do this one pool just to make sure to see who is, what kind of profile people have. Are they, more from business side or more from planning and administration side? Are they like in a position of decision makers? So it would be nice if you would answer this. Okay, a few more seconds. We still have a couple of people who haven't voted. Good. So those of you who have voted, this is what we have now. So today we have a relatively large part of scientists and developers, and less people from business, finance, and planning. This other, we are always interested in what it is. So please, you can use the questions to just tell us, okay, this is who I am. And of course, you can use the questions to pose questions. We will try to answer them during the webinar. Now, initial presentation will be done by me here, as we said. And for a start, why are we even trying to do anything here? What are we trying to do? The underlying reason is the climate change. So climate change is there, it's going to get worse, and therefore, especially in the south of Europe, the consequences are expected to be quite important, with increase in heat extremes, increase in heat-related mortality, with more droughts, more forest fires, risk of biodiversity loss, and of course, invasive species, more energy demand for cooling, issues with summer tourism, people not wanting to go there anymore because it's too hot in summer, issues with river flow, with crop yields, etc. This is kind of my pet slide, and what it shows is on the left side is how hot it was in 2003. You may remember maybe not the year, but you may remember the event when like 40 to 70 people thought to die within, I don't know, 1 or 2 weeks of this very hot weather. And this is how it looked like in that year. This is a number of hot days in 2003. And on the right side, you can see the worst case scenario, end of the century, business as usual scenario where we don't do anything for climate change or against it. And what you can see here very clearly is, and this is a yearly event, please, yearly event. Okay. So what you can see very clearly is that there are more hot days in this scenario. Here in Spain, you see in France, actually all over Europe, than in this catastrophic year 2003. And again, this is the worst case, but this is yearly. If we go for a middle scenario, RCP 4.5, and for mid of century, of course, the situation will not be as bad as this. But still, we have occasionally, our predictions say occasionally this kind of events will happen. So worse than the worst case, what we had before, is something which we have to expect. Now, clarity is, as you know, on its flag, we want to make it clear what this climate change means locally in Europe, in different parts of Europe, in cities, and also what we can do about it, again, locally. We are not talking here about changing the amount of CO2 we are producing in the worldwide. We are not talking about changing of the climate. We are talking about local activities which help us to survive and to thrive, although the global climate is changing. How? We have 3 levels on which we are working. One is the screening service, and today it will be mostly about the screening service for traffic infrastructure. Then there are expert services, which is the fully fledged expert studies concerning specific region-specific issues. So in this webinar, we will be talking about traffic again in Spain. And there is a marketplace which will not be mentioned much in this webinar, but there is a special webinar for it. Please do and take a look at it. Marketplace is a website where people who have needs and people who have offers can meet, and there is automatic matching function, and it's, in my opinion, very useful. But of course, it's as useful as it's being used. So the more people use it, the more useful it gets. Now, first, talking about the standardized workflows and reports template. One of the main results of the project was the adaptation of the so-called EUGL methodology, which you can find on this link. And we have updated it to comply with 5th IPCC assessment report. So in terms of terminology, but also to some level in terms of the workflow. And we have tested it both in expert studies and in our tools. And we are confident that this workflow can really be used for basically any kind of climate resilience study. Next thing are these demonstration cases. So today we are concentrating on road and transport infrastructure, but we had 3 more demonstration cases which were about urban infrastructure. And just to give you some idea of the results of these. So for instance, this is Naples, and this is estimated cost of the so-called ideal strategy for improving the local climate. And this is what it would be without it. This is how it would look like with it. And these are the costs. So the interesting part is these costs are enormous. But when you look at how much it costs per square meter of open spaces, buildings, etc., and also when you think about it, that these costs are not going to be paid all at once, but within 10 to 20 years, then it's clear that this is something that is affordable actually for the city of Naples, and it's also necessary, and they are already working in this direction. Similar situation in the city of Linz. This is a little bit different type of modeling, but the same kind of results. So if you look at the city of Linz, I'm not sure which scenario this is, but we have made like 3 different scenarios and 2 different timescales. And okay, it's getting warmer, and if you compare this to the past, this is really much warmer, many more summer days than we had in the past. Then if we change the land use by making the city greener, putting more water, keeping the open corridors for wind, and having like this sponge city principle where the rainwater doesn't just run away. The results is, among other, that the cooling effect can be up to 25 degrees in hot summer days, and this, of course, this is the maximum. And this really helps and makes much of this heating, which is expecting go away again, and the city remains a livable place. So much about this. You will hear more about the traffic later. Now, the marketplace, I already said, it's a website. It's on marketplace, My Climate Services U. And you can just join and then put in information in your profile, whether you're offering something or whether you're looking for something, and the system will help people find each other. Finally, the self-services. I will describe the urban screening here in short. So it's available on CSIS My Climate Service, both of them. And this website allows automated or semi-automated screening of climate risks for urban and traffic infrastructure. How does this so-called advanced urban screening work? Well, we get automated downscaling to 500-meter scale for hazards, for exposure, and calculation of impacts. Simple to use. You get results within half an hour. It's obviously not expensive. I mean, there are some expenses to host it, but it's not huge. And it can be done in about 400 European regions. Actually, it may be interesting to show this live. Just a moment. I'm here as administrator, so I can see some data, and this is the data availability. So in all these green regions, like for instance, this here is Madrid, and this here is Vienna region. So you can see these regions are about 50 to 70, well, some maybe 30 kilometers around the city. There is quite a lot of them. So like here, this is Stuttgart. This here is, I don't know what, Podgorica, it's Montenegro. Somewhere down here must be entails further down. Okay, I'm not so good in geography, but you get the idea. Okay, so I will just say a couple of words more on this. This is first part of the screening. After you have done this, then there is also a possibility to choose some adaptation strategies and see how the impact parameters change. Some of these models have been truly well validated, so we know for heat hazard that it's pretty okay, and exposure as well. The mortality impact is also quite reasonable. Some others are not completely validated yet, but we are continuing to work on this, and we are now planning implementation project with the city of Linz, where this will be further nailed down to the region of Linz. And we hope to get within a year or two really a working tool which will be used on a daily basis for all the projects in that region, and then to replicate this to other regions in Europe. So from the prototype to the actual working system. Now, this is all I had in this very short introduction. There are other webinars, and there will be also a webinar where I will be describing how to use the tool, so tutorial for the urban screening within a couple of days. Please join us if this is of interest for you. And now I should give the stage to the next speaker, which, if I'm not wrong, is Laura, right?
Yes. Okay, perfect. So thank you very much for attending this webinar. And I'm going to explain to you the work that we have been performing during this a little bit more than 3 years that we have been working in the Clarity project. Very briefly, Dennis has already explained to us what is the project. Simply, just please keep in mind that the objective of the project was to develop some kind of tools that would be online. They are on the cloud. You can access, have them on the internet. And these tools have the aim of improving the resilience of transport infrastructures and urban infrastructures. How do we do this assessment? Following the European Union guidelines that also Dennis has commented. This is very important because this is the methodology that we have followed, and I am going to explain later on. We have these 7 steps, and we have tried to stick to it as much as possible. I will be explaining now how we have taken into account each of these steps on our transport tool. Where can you find it? As Dennis has said, it is available at myclimateservices.eu. We are also trying to implement the tool in the CEDEX website, so we can also have access more directly. But we are still working on this. To begin with my presentation, I would like to explain very shortly why we decided to perform this pilot study in Spain in a road section. We have a very wide transport network. Maybe some of you already know, but just to give you some hint, we have more than 26,000 kilometers of highways and more than 165,000 kilometers of roads. This is the state network, okay? We also have more than 2,600 kilometers of high-speed train. So we have a lot of network that we have to maintain in the best possible conditions. 2 years ago, we already performed a previous study trying to identify what were the main challenges, the main climate challenges that we are facing as road owners and railway owners. And we estimated that already at the present moment, approximately 45% of the network is already suffering some kind of impact related to weather events, mainly rainfalls, but also other issues like wind, snow, blizzards, etc. A very interesting conclusion was that 6% of the network, I am talking now of the road network, was already suffering from important impacts. So we decided that it was important to identify what were the sections that are mostly impacted and what are those impacts and what things can be done to try to reduce the impacts and make the network more resilient. So from this work, one very interesting lesson that we learned was the identification of the main impacts on the roads because of climate events. As you can imagine, most of these impacts are related to rainfalls and consequently to extraordinary floods. Here we have a picture. It's quite common to have this problem when there is an intense rainfall concentrated in a small period of time. Other impacts we are very used to see in our roads. We are talking about landslides and erosion, falling of materials off slopes. We also have problems with embankments when we are close to the course of a river. problems of erosion of abutments and foundations on bridges and viaducts. And also, very important, we have to check the capacity of drainage works and the capacity of road surface drainage. Not only we have to think of rainfall, but also it's important to see the impacts related to extreme temperatures. Now we are talking about the impacts to the traffic circulation, maybe due to wildfires, also related to snow problems. And when we are thinking of the infrastructure, we also have to pay attention to pavement cracking and the appearance of plastic deformations on the road surface, sometimes related to very low temperatures, sometimes related to very high temperatures. So now going to the methodology that we are going to follow, and having in mind these things we had already learned. The first step was to identify the main hazards. When we talk about hazards, we needed to identify the climatic variables. Sorry?
Oh, sorry.
Okay. We have to identify what are the climatic variables that we have to assess. As I have already said, we are talking about maximum temperatures, minimum temperatures. Also very interesting to pay attention to the number of days below 0 degrees, okay? We are going to pay attention to intense rainfall and to the fire probability of having fires close to the roads. What do we have to do to assess these variables? We have to define indexes that will try to explain these climatic issues. We have had the support of meteorological institutes. In Spain, we have been supported by AEMET. We will have a presentation later on where Ernesto is going to explain to us what indexes have been used in the prototype, what is the science behind these indexes, and also some issues very interesting related to uncertainties. For the rest of the project, we have also have the support of other meteorological institutes that have calculated this information for the whole Europe. With these indexes, we will be able to assess both the road elements and also, very important, the affection to daily traffic on our roads. The next step would be the exposure analysis. Exposure analysis means to identify the road elements that might be impacted by climate events. For example, we have here a slope that was identified like a vulnerable element because there may be some problems related to intense rainfalls. For these elements, we have to locate them on the platform that we have developed, and we have to define some attributes that are going to be somehow related to the climate event that we are going to assess. The next step is the vulnerability analysis. Here, what we are going to do is for each element, for example, the slope we were watching in the previous slide, we have to study the severity and also the probability of the climate harms on the exposed element that we are going to study. We have to assess both aspects, severity and probability, in different time scenarios, at present, at a medium future, and a long future. This vulnerability analysis is a very important step in the whole process. It can be done through vulnerability functions, or it can be done by means of the expert assessment. In the Clarity project for the transport infrastructure, we have followed the expert assessment. Why? Because we understand that in order to have vulnerability functions that are reliable, we need to have a big database of events and consequences. For example, for the slope that we are studying, we would need to have some registers where we can relate different rainfall intensities with the consequences of this rainfall in this slope. The problem is that we have a lot of different types of slopes with different heights, with different materials, with different degrees of inclination. And having this database is an important effort that we don't really have it for the Spain road network. So we have asked different experts to assess what were the possible severity and probability labels according to the climatic information and predictions that we have from our colleagues from IMET. They have helped us to assess if the impact was going to be low, medium, or high. Then the next step, which is the risk analysis. This is a semi-automatic step, because having the information regarding the integrity and the severity and the probability, we can assess if the traffic conditions and the element is going to be have a low, medium, or high risk. This is done by means of a matrix that can be calibrated by the road owners or the expert that take part in the study. Then it's very important, according to the level of risk that we are going to assume, we have to decide if it's okay or if it's not okay. Depending on the importance or criticity of our network, the level of risk that we are going to assume is going to be different. And then if the risk is not assumable, we have to propose different adaptation measures. This table was done with a list of measures for the slope that we were watching formerly. And there is a list of adaptation measures. Very important, we should make also an estimation of the cost of the measure and the expected efficiency of the measure in the case we implement it. According to this assessment, it should be done a cost-benefit analysis and propose an adaptation plan for our infrastructure. In the case that the measure is implemented, we can reassess the risk in our road section and see if the improvements are going to have a positive impact in the study that we are performing. In any case, it's very important that this adaptation plan is integrated in the maintenance strategies of the road owner, and it has to do with the conservation strategies that we are going to implement in our road. So this is the process. This is the work we have tried to done within the project. And just before closing this presentation, I would like to insist that this is something very interesting, and we want to continue working in this topic. Strengths of the project, I would outline having a structured approach to these climate change vulnerability assessments. It's not something difficult, but the first time you have to do this assessment, it's not easy. So I think it's good to count with this structured approach to do the assessments. Also very important, we count with an online application that is going to support the whole process. Very important, the help with the climate projections and helping you to follow all the steps that have to be done. And finally, for me, it's very important that we as road owners and road practitioners become used to include this climate information in the decision-making procedures. And I think it's going to help to have this more resilient and more adapted road network and railway networks. So this is it from my side. Please contact us if you have any doubt. And I hope the rest of the webinar will help you to understand what we have been doing in this pilot. Thank you, Dennis. This is it from my side.
So Ernesto, you are the new presenter now, so you should be able to, yes.
My presentation is about the principles of climate information, how we produce and use the information we generate about climate change projections. There are 2 or 3 main ideas that are below this information, and I will insist on these ideas. First point that I would like to comment is about the future world. Well, we don't know how will be the future world in terms of concentration of greenhouse gases. And as we have a high uncertainty, what it is usually done is to present some kind of alternative scenarios. This is the so-called representative concentration pathways. The idea of these pathways is to translate information of the future world in terms of concentration of greenhouse gases. And one way to concentrate greenhouse, to show this concentration of these greenhouse gases, the most important is CO2, but also methane and others, is to express everything in terms of CO2 equivalent. And what we have here is different alternatives for this future. The different alternatives are expressed with different numbers, 2.6 up to 8.5. This gives us some idea of the imbalance in the climate system. How far away our system is from the equilibrium. 8.5 corresponds to a system which is far away from the equilibrium because we have emitted a lot of greenhouse gases, and 0.6 is very close to equilibrium. 8.5 corresponds to high emissions, a very pessimistic future, and 0.6 a very optimistic and green future. We, of course, can translate this imbalance expressed in units of energy. We can express it in terms of concentration, parts per million of the CO2, which is the main gas. This is for the pathways we have used so far. In the next IPCC projections, we will have a combination of socioeconomic scenarios, socioeconomic pathways, and imbalance pathways. The representative concentration pathways. So we have for the next generation of scenarios, we have a combination of these RCPs going from 2.6 to 8.5, going from low emissions to high emissions, with some representation of the socioeconomic world. For example, we have the so-called SSPs, share socioeconomic pathways. Here we have, for example, a world which would be based in sustainability or in fossil fuel development, or in terms of will be mainly characterized by inequality or regional rivalry, or something in between, which is the SSP2. So this is the next generation, would be the standard for the next projections. The next ingredients are the climate models, which are now also named Earth system models, as they have a representation of the carbon cycle. Climate models are simply the equation of the different components of the system. Here we have the equations for atmosphere, which are used for weather forecasting, and similar equations for ocean, for cryosphere, or equations for the biosphere, for vegetation, and for other components. These equations are discretized and solved in a grid, which usually, and with the limitation imposed by the current generation of computers, they have a horizontal resolution of about 100 kilometers or 150 kilometers. Then the equations are solved in a very large computer codes, very efficient and quick computer codes, and also some representation of processes of scale smaller than the grid square is also included, the so-called parameterizations. So climate models are based on physics. This is the important message. Based on physics and solved with the latest generation of computers. So a climate model, as it is written here, is a numerical representation of the climate system based on the physical, chemical, and biological properties and equation of its components. Also, their interactions and feedback processes are described by this equation. The next idea is that the atmosphere, as we all know, is a chaotic system, and also the climate system, including all the components, not only atmosphere, but ocean, cryosphere, and so on. The system is chaotic, and for representing such chaotic system, we need many simulations, many realizations of the system, of the equations. So we have the chaotic nature, the uncertainties. We have uncertainties coming from the climate models. Not all climate models are the same. They have different ways of discretizing the equations, different approximations. Also, downscaling algorithms are different. All these steps have uncertainties attached. So in order to have a clear representation of the uncertainties, we need to generate many realizations of the evolution of the climate system. With this many realization of the climate system, we have to make use of a probabilistic approach. And in order to fix the ideas of this probabilistic approach, I have use of this pinball game. Here we have different balls. The evolution of one single ball is not relevant. What is relevant is the distribution we have here. And this distribution gives us some idea of the climate and some idea of the uncertainty in the description of this climate. If we have a very wide distribution, we have a climate with high variability, or we may have a climate expressed with high uncertainty, with the uncertainties coming from the sources I have already mentioned. So if we want to describe the climate, we have to describe this distribution. This is for the current climate, for the current situation, but imagine that we have some perturbation. In the case of the pinball, it could be some tilting of the pinball game. This tilting, what is causing is some shifting of the distribution. This perturbation could be associated to the emissions, man-made emissions of anthropogenic emissions of greenhouse gases. So what we have is one distribution and some perturbation which is causing some modification in the distribution. But always it's important to have in mind that we should have a probabilistic approach. The next ingredient is the usage of downscaling. As I have said, models have some maximum horizontal resolution of around 100 kilometers. This is clearly insufficient for most applications. We should try to enhance this horizontal resolution. And in order to do that, we have two typical techniques. One which is based on dynamical methods, which mainly consist on nesting high resolution regional models nested in global models. The high resolution models are solved for the region of interest. And with this dynamical technique, we may easily reach, for the case of Europe, around 5 kilometers, which is closer to the needs of most applications. We may alternatively use statistical algorithms which relates grid squares from the global model, from the climate global model, with point values. And in order to generate this function relating information from grid points from models with observational points or of finer scale points, we need a long series of observations. So with these ingredients, the emission scenarios, a collection of global models, and a selection of downscaling techniques, we are able to produce evolution with some range of uncertainty, which correspond to the different realizations. Finally, we have to distribute all this information in two ways, using our repository of information. Here, most of the data are numerical data, and we also make use of a viewer. This viewer is able to present and facilitate the download of information for different applications. And this viewer is feeding our specific information system for roads. So we have three ways of distributing information: the repository, the viewer preparing the information for different applications, and the climate services information system for road, which is able to read directly from the viewer. How is the situation in Spain with respect to climate change projections? Well, our main interest is to populate as much as possible the simulations in order to have a clear and better representation of the uncertainties and the distribution which appear in the climate, including the different types of uncertainty. Here in this scheme show the different uncertainties which are represented with different realizations. Well, what are climate indices? Well, climate indices are relatively simply magnitudes which are used for evaluating climate features that could be relevant for different sectors. For example, we all know that temperature and precipitation is very relevant for most of the sectors and are defining the climate, but not all features of temperature are relevant for different applications. Here, what we have to do for the definition of climate indices is first to identify road elements, for example, pavement cracking. This is one element of the roads which are affected by minimum temperature. And for example, the temperature below zero or below certain threshold are critical for the state of pavement cracking. The same for other road elements, rutting or reach of fire index for maintenance and exploitation, of the amount of intense precipitation. It would be relevant for drainage of the roads. So we have to select some indices which are relevant for the different road elements. What we have used for this project is to use Eurocordes projections. But of course, that was one election. We also may have used other alternatives. We have used this Eurocordes projection for several reasons, mainly because it is some standard in Europe. They are expressed in the same format. They produced for different scenarios, and we have computed for 3 different time periods. And also we have selected some indices which are relevant to different road elements. For example, stream mean temperature, sun percentile, height percentile, or for maximum temperature or minimum temperature, or daily temperature oscillation. Daily temperature oscillation give us some idea of the difference between maximum temperature at a daily time scale, maximum and minimum temperature. And as you can imagine, the asphalt, the road suffer, especially with this high oscillation in temperature. So this is a very relevant index. This is some example of outputs with different realizations coming from different global models, from different regional models for downscaling, and for the average, here we have the RCP 4.5 and RCP 8.5, which correspond to high emissions, and the percentiles 99 of maximum temperature. We have representation similar like this for a collection of indices. Now, let me give you some few words about the future. As I have already said, this information comes from different steps. We produce a lot of realizations. We include it in the repository. Then the information go to the viewer, and from the viewer goes directly to our application for roads. If we update information with new IPCC cycles and with new downscaling, almost immediately this information is inherited by the repository, the viewer, and the roads tool. New indices could be suggested by specific users, or in particular by users coming from the road transportation, and could be very easily implemented in the information system of Clarity. And finally, let me insist in the idea that the probabilistic approach is basic, is essential, and we always intend to have the simulations populated with many members, with many realizations. We give us a better estimation of the projections distributions, projections PDF. And this is the main ideas behind this climate information feeding our tool. Thank you.
So I've seen a couple of questions. So one question was about how did you determine the sensitivity of the assets for different hazards? So how was this done? I know that this is not a simple thing to do.
Yes,
I know that in the end we decided to let people decide in the end because they are experts, but there was quite a lot of work going in this direction. So maybe Laura?
This is not a simple question, as you said. If we have a look at the European Union guideline steps, doesn't really express a sensitivity like one single step. So what we have really done is when we do the exposure assessment, we have to take into account not only where the element is, but also we have to take into account its characteristics, like, for example, how old the element is, the maintenance that has been performed up to the date. And as I was explaining, for embankment or a slope, we have to take into account the materials, the height, etc. So this is, I would say, this sensitivity analysis. Then, when we perform the vulnerability assessment, it's when we incorporate this knowledge that has been provided by the expert. That might be the conservation staff, the road owner. It would be very interesting if we can count in the team with, for example, some geotechnics expert or some hydraulics expert if we are talking about drainage works. And with this information, we can assess the probability and the severity. And we do this in a qualitative way because we have some predefined scales ranging from low to high, and we explain also what means each one of these labels, but it's something qualitative. I hope it was more or less clear how we do this step.
I hope so. So then there is this other question also for Margriet van Marle, which is about the climate change scenario. How are they validated against the station data? E.g., how it's based, which Cordex models to include or not to include, especially for impact assessment for extreme events. The usage of all models might result in underestimation of extreme events. So I'm not a climate expert, but I've been leading the project, so let me just start with answering this partially. And the partial answer is that all of the climate models that we have in CSIS, they all are a assemble of models. So we have different models, and the average of them is given out as a result. In addition to the actual result, there is also a possibility to take a look at the uncertainty, difference between the models. And it's true, of course, that we are not getting the most extreme. We are getting kind of average result, which is what we are advertising. But the user can easily find out what is the difference between the lowest and the highest estimates. So I believe that this is quite, well, the best you can do. But maybe somebody else can answer this with more details. As I said, I am not a modeler.
Well, just an additional comment. Of course, if we average models, we have a relatively good first approximation to the evolution of certain variable of certain index. But this is not enough. Of course, it would be much adequate to have some estimation of uncertainty and going to the highest value and to the lowest value to have some idea of the uncertainty. Some variables show less uncertainty. This is the case of temperature. But if we go to indices derived from temperature, some of them are increasing the uncertainty. For example, we may derive some index based on the duration of heat waves, for example. This index is based on temperature, but if we represent the duration of heat waves, using all sources of information coming from global models and from regional models, we see that the uncertainty is rather wide, rather big. So to have some idea of how wide is this uncertainty is very relevant, and not simply to take the average value. To summarize, the average value to have a first hint of the evolution, and if we want to be more accurate, we have to look at different evolutions, not only just one evolution, some average. And even if we have many of them, we will have a very clear representation of the distribution of the evolutions.
Okay, in the meantime, I'm showing my screen now. I believe that you should be seeing this. For each piece of data which we have in the so-called data package, we are also providing the complete description of how it's described, which is visible for users. So in this case, the next question was which models. Honestly, this is not telling me anything, but for modelers, this is probably enough to understand what we did. So this was, for instance, was calculated by Austrian Central Institute for Meteorology. And these are the models which went into assemble. And for each of data pieces which we have in the data package, which are used for this kind of assessments, all this information is available in the system. I hope this helps.
Yes, and for most of the variables, we are not only providing the mean value, but also the statistical deviation of the values between all the models. So
Yes,
in order you can have an idea of the uncertainty associated with which is one of the scenarios.
Yeah, that's what I already said. And as Ernesto already mentioned, it's kind of pity that we are not showing for indices also, like, okay, what would be with minimum, what would be with maximum, what is the mean value. But it would kind of be a little bit messy to show all this on a screen. The data is there. We could calculate it. Probably we should calculate it. We did not find a very nice way to present it. That's the problem. Okay, so Jaime, I saw that you were getting yourself ready.
Yeah, I think we can continue with the webinar.
Okay.
Let's see if I can share my screen.
You should be able to do it now.
So I guess that you can see my screen right now. So is that right? Can anybody confirm that my screen is being shared?
Yes, it's.
So we are going to continue right now. I think that Dennis gave an overview of the project and why the need of this getting into the research and innovation of trying to develop an overall system and methodology.
We have basically done all the presentations. Now we are looking for real demonstration.
Real case. Yeah, real case. So what I wanted to show you right now is, after the introduction from my colleagues and the explanation about why to invest efforts on this, it's a clear example in a highway, in a study in 70 kilometers track of highway in Spain, transport infrastructure. Okay, just to give you an overview, what is located. Okay, it goes from near Madrid. It's about 35 kilometers away from Madrid, and it's the main communication highway, let's say, in between Madrid and Barcelona, which is located here. Okay, so it's just the main well, traffic connection, and there's no other alternative at this point, at least with this traffic capacity right now. And well, how the methodology was designed and was also previously explained by Dennis in the clarity approach, and also by Laura about the needs of this type of research in transport infrastructure, and also after explaining by Ernesto the climate indexes that we have been used to calculate this into the tool. So we well, also the well, this is the system, how it looks like. Okay, the website. So we have 5 different steps. Okay, as was already previously mentioned. We have to, when we have a transport infrastructure, first is necessary to characterize the hazard, to evaluate the exposure, to make a vulnerability analysis, and to make a risk and impact assessment. Okay, so first, how we have been worked with this track, highway track. Okay, we firstly worked with the people from the maintenance service of the road. So this is a 2 lanes highway which goes from Guadalajara region to almost to the limit with Soria, in the middle of Castilla-La Mancha and Castilla-León, which is a region in between Madrid and Spain. It's a rather high altitude highway. It begins in the first kilometer of track at nearly 800 meters of altitude. That it ends at the kilometer 135 at more than 1,200 meters of altitude. So the winter maintenance, it's a key issue in this track. So we mainly went through the road design and identifying the possible spots where the exposure. So the exposure analysis, we went through the slopes and different asphalt characterization and possible problems according to the experience of this track and the people making the maintenance of this track from the previous year. So we identify different overpasses or down passes of the highway. All the drainage systems have been identified and have been spotted into a table. Okay, we identify it, we describe it along the highway, along the track, talking with the engineers, with the designers, and with the responsible of the maintenance. So this is the final part of the concession. So it's a rather high traffic intensity road. Okay, so once the exposure analysis has been done, we go to the tool. Okay, and the tool let us also characterize each of the tracks. Okay, let me put this down so I can manage. And here in the system, we can plot out a map with the all identified points. So this is the track that you have seen previous in Google Earth, which is rather more visual. And I'm going to choose another map, okay, because it's better to understand. So this is again the track, and the system allow us to identify each exposure point, possible exposure point. Okay, so how to identify and how to add a new exposure point in our track, for example. So we went to the exposure evaluation step. Okay, again the map has to be loaded. Let's go to the okay, and we can make a zoom. And for example, so we have identified here different bridges and different infrastructures of the road which may have of interest making the analysis. Okay, so we can identify different type of infrastructures and different point of vulnerable points. So we can identify drainage or drainage rivers, different type of tarmac or pavement infrastructure, linear drainage, transversal drainage, overpasses or down passes, or even different type of slopes. Okay, or even we can identify in this case, because it was also an open issue, different types of winter maintenance points, where, for example, we have accumulation of snow in a certain point, of accumulation of ice due to the a shadow zone or whatever, according to the system and to the experience of the maintenances. So we can the system allow us to identify one specific point, like, for example, I'm going to make an example to create, for example, one, well, let's say one of these, for example. So we can identify it's in the kilometer point, let's say 75, and it's a drainage system. Okay. Okay, so we can, let's see where the system creates the so the systems
in the not in the bottom, but in the upper.
Here, okay. We can identify here, for example, one line. I think it's already created somewhere in the map. Okay, let me see where it is. Okay, here. Well, somehow we are allowed to create different type of vulnerable points. Okay, and we can later here. Let me see if it's this one. Well, we can. We can identify in the map. Okay. And even we can identify in a table. Okay, so we have identified all the exposure points, for example, according to the type of infrastructure. So, for example, in the case of slopes, we have different slopes created at different kilometers along the study track. Okay, we can erase them, we can modify them, and or add some information about it. Okay. Slopes, river flows, different type of platforms or tarmacs or asphalt pavements. Okay, so and identify different problems. For example, not enough drainage capacity, or problems by intense rain or heavy rain, or identify, for example, physical problems of the pavements, where deformations due to heat waves, or deformation to the elastic behavior of the pavement. So different, again, transversal drainage, identifying different points along the road. So the system allowed us to make groups of elements along the road, and also this is the winter maintenance. For example, it's in Spanish, but well, the different points of winter maintenance problems identify along the road, and which are positioned in each. So we can identify them in the map. Okay, as I already showed you. Like, for example, here with different points, and in the table. Okay, so the first step, which is the exposure evaluation, it's already done. I mean, because in this case, in this example, we have all the points already loaded into the system. And the second step will be the hazard characterization. So we have identified the points along the road which may have problems due to the different type of climate hazard, okay, which has been already identified and also explained. Let's see the map. I'm going to show you how the maps works, okay. And also, as previously explained by my colleagues, by Ernesto and Laura, and according to the type of infrastructure, why the map is not loading? Yes, okay, here we are. So we have identified the exposure points, the possible exposure points, and then right now we're going to make the hazard characterization. So which is the hazard? The hazard are the different climate indexes that we have defined, which may be important in a transport infrastructure, and which are them. So here we have them. So all of them dealing with precipitation, mainly heavy rains, and periods of also intense wind. Okay, we're talking about an infrastructure, but in this case, in this specific case, the wind is not so important, but maybe in others could be of interest. So included also one climate index regarding wind, strong winds. So mainly maximum daily temperature, percentile 5 of minimum daily temperature, thermal amplitude, precipitation, maximal precipitation in 24 hours, maximal accumulated precipitation in 5 days, and maximal consecutive days with precipitation. Okay, so all of them for two climate scenarios, for the RCP 8.5 and RCP 4.5. Okay, so we identify climate indexes regarding precipitation and regarding temperature mainly. So for example, if we select for example maximum daily temperature, this one, so the system get the values, okay, from each point along the road and give you an overview of the well, in this case it's in the year 1970, okay, so past climate, but we can move along this bar up here, and we can move along the years, so we can have estimations. Okay, so we can see here we have higher temperature down here because mainly due to the issue that I explained before, that here we are at lower altitude that here we are talking about almost 300 meters difference of altitude in between this kilometer and this kilometer. Okay, we're talking about 70 kilometers distance. And if we move just to have to check the variation, so here you can see how the colors are changing, and we are getting higher temperatures in the estimations due to the climate change and specific for this climate index, which is the maximum temperature. And if we will move forward to year 2040, come on here. So the systems again calculates, takes the data from the base data where this percentile of maximum temperature is calculated and plotted into the system. Okay, and if we move forward to 2070, okay, which is along the years, okay, we can feel the difference very good. Okay, and for example, if we plot this all together, like for example in this slide, let me see if I can plot this to the big screen. So This is the percentage of maximum temperature, daily maximum temperature 1970, 2010, and 2040 for the RCP 8.5. So we can have an overview along a rather quite large track, let's say, and we can think about how this may affect the infrastructure or not in the case of the temperature, okay? So this is very good, okay, it's very visual, but we can also have the same data for each specific point. So if we go back to the table where all the previous points were tabulated in a table, okay, and we select the percentile 95 of maximum daily temperature, okay, so for each identified point in the map, the system calculates, go to the base data and comes with the data for the specific temperature in that point, in that kilometer, for the different periodic scenarios from 2040, 2070, and well, 2000. The year 2100, okay? So we can have the system allow us to have an overall overview for any specific climate index that we have previously calculated, okay, as was explained by Ernesto, by Ahmed. And right now, for example, I'm going to show you the precipitation, okay? Maximal precipitation in 24 hours, for example, this one. Here we have the scale, the colors scale in millimeters day, okay? And let me see, okay, again. So I think you can feel the difference. So we have lower precipitations here, higher precipitations along as we are moving high in the mountains. But for example, if we go to the estimations for 2040, so we are going to have more intense and heavy rains all along the road, okay? And even in 2070. So it seems that, for example, if we have right now, if we in this track we have some drainage problems, or the drainage of the pavement in certain points, it's rather problematic right now. Yeah, if we continue with the same type of pavement and or the porous systems or the drainage systems are not well maintained or well repaired or even increased, we may have more problems along the years, okay? Because it seems, according to the estimations, that again, if we go to the table, just to have a specific overview of each point, okay, the systems goes to the base data and comes again with the data of how well, this is the maximum temperature. I'm going to plot, sorry, the maximal precipitation in 24 hours, okay? So we can, for example, if we go to the drainage systems, okay, here, for example, let's wait to the systems to calculate, to come back with the data. So we are going to have, for example, you can see this example. So we are increasing from 29 millimeters to 34. Well, it's not a rather big increase in precipitation, but it's something that we have. I mean, the maintenance people and the people from the road maintenance or the truck system maintenance must be aware of. Okay, so again, so we have the step one. We have the exposure evaluation, the hazard characterization, and then the system allows us to make the vulnerability analysis. Okay. So again, and also as previous explained by Laura, in this case, there are not a specific. We haven't identified a specific formula or simulation for the vulnerability analysis, and we the system, we decide to design a system according to the like for example, in this case, it's a track, it's a road. It's not a new design of a road, but it's a road which has been exploited during the last 10 years. Okay, so it's an open track, and we have data from the exploitation and maintenance issues. So the system allowed us to well, to characterize each element, each point, and we can define, or we, the designers, the engineers, or the road maintenance experts may make the exercise to define the vulnerability. So for each point in the map, which we have previously identified in the map, in the table, and also in this table, we can define the integrity of the specific infrastructure from 0 to 6. So from inexistent 1 to very important 6. So we can define the severity and the probability of the issue to happen in this specific point. So from 1 very weak to occur, and 5 it's very probable to occur. So so we can define also the integrity of the element along the years and according to the data, to the climate data that we have previously analyzed. So we have to look into, to make the previous exercise, which is we have all the elements of the road. We have analyzed them with the hazard characterization, and we, I mean, the expert criteria decided if the integrity and the severity of the exposure to the climate index, specific index, is rather severe or weak, and along the year. So for the different period scenarios in years, so from year up to 2040, 2070, and or to 2100. Okay. And even though the system also, depending on the, we have defined what is called the traffic conditions operation, or traffic operation conditions. How the integrity of this element may affect the traffic conditions. Okay, so and how may affect the severity and the probability to occur. I will explain this better with a picture from the road. Okay, for example, if we go to the first point of the track, for example, here we have identified several exposure points, like for example this slope. Okay, we have here a slope which has been identified, and it's a slope which is with a rather, let's say, erosion soil, okay, which may have problems. But how this may affect, or if this soil collapse into the road may affect the circulation. Well, for example, it may not cause a big issue into the circulation, as it is not in the main track of the road. But for example, if we go to this one, okay, this other one, which is in another specific point, okay, what may happen if this slope collapse, or part of it collapse into the due to the or heavy rains, or mainly not a good drainage of the system, and so on. Well, was here the affection to the traffic, or to the circulation, it's much higher. So this is also the system allow us to identify it and to define, for example, here. Okay, so we can identify the severity and the probability to occur for each specific action area. And well, and the next step in the system, the fourth step, the system calculates according to the climate evaluation, and according to the data that we have introduced in the table, it creates a matrix, okay, where each element of the road has been identified and the risk assessment is being calculated from high, medium, low, or negligible, okay, despreciable in Spanish. So the system plot us for each specific point of the road, and according to the climate indexes that we have calculated and we have identified to be important in this type of transport infrastructure, okay, how these elements are being identified due to the risk and climate risk impact and assessment, okay. Again, the system allows us to plot the systems in a table, or we can have a look to the track, okay. I'm going to plot the other map where we have a better view of the system. So, for example, in this case, and according to the type of exposure point that we have defined also the system plot us different colors where the risk is medium, high, or low, okay, red for high risk. In this case, here we have the pavement in red because we have identified here the winter maintenance issues, and also the drainage systems, as you can see from the beginning, okay, that we are going to have more intensive rains along the years in how is the predictions coming on. So here the system tell us that we must take care of the drainage systems or the winter maintenance systems along the road, apart from whatever kilometer, okay, here. So it makes differences. So you can identify, or you can make a vulnerability assessment in a map or in a table as it was plotted here, okay, for each point of the road. So, and to finalize, the last step of the methodology and the last step of the system is just to propose different and to identify the different adaptation options, try to mitigate the possible risk identified according to different climate indexes that has been studied for this type of infrastructure and for this specific track. So the system allows us to propose and to identify different adaptation options according to the type of infrastructure. And in this case, and for the traffic issue, we are working on incorporating to the system different, let's see here, different adaptation options according to different identify problems regarding slopes, regarding drainage incapacity, or regarding well, problems of mainly those type of problems has been identified in this road highway track infrastructure. So we are on the way to incorporate this into the system, just to evaluate and to model how these adaptation options may decrease the risk in this type of infrastructure. Okay, and I think I made an approach from all these 5 steps of the system. I think that that's all from my side. I mean, the system has the powerful to analyze different climate indexes along a specific highway track. It's also valid for road infrastructures and also for railway infrastructures. I don't know if you were planning also, Luis and Dennis, to make an approach to the railway example, but as I think we are behind schedule, I think we can. Well, this is all from my side, I would say. Okay.
So thanks, Chaim, and please, the rest of you, could you join us? Hey, Chaim, come back. We have the final discussion. Laura,
Okay.
Ernesto.
Just a few remarks. The information we have seen with José Cubillo is it's handwritten all in Spanish, but the system allowed you to show the information in English. It depends on the configuration you have on the browser you have. So all information is in English if you're not Spanish. Right now there are only these two languages. Let's say the Spanish and English, but it's quite easy to incorporate new idioms into the system. The information for Spain is based on the information that IMET has calculated in the project, but the information for all over Europe is the information that the Meteorological Institute of Austria has calculated in the system.
Okay, thanks. Now, I think one thing is interesting to mention. When I compare this traffic application, the screening with the urban screening, what I notice is that on one side, the traffic application is, let's say, more appropriate for really using it in daily work. It's more aligned with the way the engineers work. But on the other hand, it's doing less actual calculations. So in this traffic application at the moment, it's mostly, I mean, it can be, in my opinion, described in a short term as we show the engineer in charge of road what they want to see. And then it's up to them to decide what is really the part which needs more attention or not. And the system will happily accept their input and make it presentable in a printable form as a report in the end. Is this correct in your opinion as a current status of work?
Yes, I think it's correct in my opinion. I mean, in the urban screening, we have developed a thorough tool in order to calculate the vulnerability of the different elements. Here we are based on the opinion of the engineers that maintain the road. There is not vulnerability functions, but there is not vulnerability functions because there is quite difficult to define vulnerability functions for the elements of a road.
I think the difference is that we have a lot of possible vulnerable elements with very different typologies, and also we have a wide range of impacts. However, I think we have to continue working on the giving some hints to assess the sensitivity we were talking previously.
Yes, I hope that we will manage to start some exploitation with what we have now. It seems to be quite useful. And for the future, it would be really good if this would be then extended with some hints. And I really say hints because looking at what we learned in the project, just saying, okay, this is how it is to the experts, it's probably not the best approach. But telling them, well, you know, we believe that this is slightly or very much sensitive to rain or to freezing or to high temperature. But if you don't believe so, you are able to change it and then let us calculate what the results are. I think that this is probably the best approach for the future. And in addition to this, we discussed already sensors. I mean, the reality is as it is, and we can always approximate it by models. But in the future, we will need to incorporate the results from sensors to see how near or how far we were from in the last round, and then improve based on that. And I think in that way, with the time, we can make a really amazingly good tool from what we have at the moment.
I also think it's, I would like to point that it's important to count with a good expert panel to do the assessment, someone who really knows the road. But also if you want to do a more detailed analysis, it's good to have people who knows from drainage and people who knows about geotechnics, and this will give more support to the assessments.
There was actually one among these questions which was like, well, from my old friend Mark, like, hey, but what do you do with debris? Because in certain configurations, the debris will come down the hill, and this will be the main problem you have. And I think that modeling this is relatively difficult. You have to model on a very, very tiny scale. But knowing where the debris will come, because that's where it comes every year, is something which is probably much easier. And so it can be taken either from existing knowledge of the expert or from sensor measurements. And that way can be then combined with the simpler models.
Yeah, I agree with you.
Jaime, famous last words for you.
Well, I hope that we achieved to explain the powerful of the tool. I think, especially regarding for traffic infrastructure for roads which are already built and are also exploited, it's a good methodology and tool for make the assessment. That just to mention also at least in Spain, the regional administrations are starting to be aware of this. Vulnerability, risk and vulnerability assessment of due to climate change in infrastructures, and I hope that this tool may help to make these studies regarding the regarding the possible impacts of different climate indexes, at least the ones that we have reported here, could be used for make estimations and try to redesign some part of this transport infrastructure if needed. Okay, and that's it.
Yeah. Okay. Before we call it a day, I'm looking at participants. I see that Akrivi Chatsidaki, I'm not sure how to pronounce that, has his hand up, and I have unmuted him or her, I don't know. So would you like to ask or tell us something?
Me?
Yes.
Sorry, it was an accident. I didn't want to raise my hand. Sorry.
Okay, no problem.
I'm sorry.
Yeah, if anybody else would like to ask or say something, please hands up or stay forever silent. Okay, I think that's it. There is, let me see if there are any new questions.
No, I don't think
just
so.
some comments from people thanking us, and that's it. Good, then I would say thanks everybody for joining us. Thanks for the presenters as well, and hope to see you on another webinars of ours.
Thank you. Bye.
Okay.
Bye
Thank
bye.
you.
Bye bye.
Ciao.